Okay, so what we're talking about, yes, the point here, x equal to 2, right? So when you talk about a limit as x approaches 2, right? So that means we've got values here. Let me see if I can just zoom that in a little bit. Okay, so what happens is this. When we are moving across on the x-axis, moving along towards this point, 2 there. The question now is what is happening to the value of the function? What is happening to f of x, right? So obviously the closer we get to 2, the closer f of x gets to. Well, let's see, if x is equal to 2, what is y? So that's 2 by 2 squared plus 1, which is 2 by 4 plus 1, which is 9. So x is getting closer to 9, okay? So as we get closer to 2 on the x-axis, it means f of x there is getting closer to 9. That's what the limit means, right? So even if I'm going to do it from the other way, as I move towards the x-axis, I'm getting closer and closer and closer to f of x equal to 9. So that basically is what limit means, okay? So when we determine the limit of f as x approaches 2, we do it like that. So how we're going to write is this: the limit, okay, as x approaches 2 of our f of x was what? Was 2x squared plus 1. Is going to give us 9. So that is how we're going to write it. Okay? So the limit as x approaches 2 of that gives us 9. Okay? So we could try it at another point on the graph and we can see what happens. Okay? So that is how we define what is called a limit. Okay, just to make it simple, if you want to find the limit, you're just going to replace the x value in there and find the y value. But don't make it like a substitution because it's not really a substitution. Okay, so that is how we work with limits. Alright, so the limit is x approaches 1 of that is going to be what? Okay, the limit is x approaches 1 of 2x squared plus 4. No, we're not going to say 2 times 1 squared. We're not going to do that. We're just going to find out when x is 1, what is the y value equal to. Okay? Okay. So 2 by 2 by 1 squared plus 4. Okay, so that is 6. Okay, that's how we find the limit.
Is it a little?
Mm-hmm.
The graph makes it so much clearer.
The graph is just to explain why do we say limit and why don't we say substitute. Because substituting and limit is two different things. So we're not dealing with the coordinate here, we're dealing with the limit now. That's why you rewrite that. Problem if it becomes not over not. That actually is a problem, okay? So it's equal to not over not, which we call this indeterminate, which means you can't do this. So what you're going to do is, rather we're going to say, okay, the limit is x approaches 1 of x squared minus 1 over x minus 1. So rather let's simplify this algebraic expression first to have one statement that we can find a limit for. Okay, so we can say, all right, so this is x approaches 1. So the limit is x approaches 1. You can't leave out the limit if you do it wrong. Okay, so x squared minus 1, well, that's a difference of 2 squares, isn't it? So we can just make it a difference of 2 squares. X minus 1 by x plus 1 divided by that x minus 1 that was there. Remember those algebraic that we used to simplify in grade 10? That's why we were learning those things. We're using it now. Okay? Obviously, these then cancel out.
Then we left with x.
So we left with the limit is x approaches 1 of x plus 1. This limit we can find. We can find this. It's easy, isn't it? It's 2. This limit is 2.
This is nice.
Right. Okay, so D, the limit of that. We also have to simplify this first, because if you try to do it straight away, we're going to divide by 0. And it's not possible. So we have to simplify this thing first. Okay? So, let's do that. So this is the same as the limit as h approaches naught. Okay, this one is squared, isn't it? So we have to expand it. 2h plus 3 by 2h plus 3 minus 9 over h. This one we're going to use our FOIL expansion, because we want to make it as simple as possible so that we can find the limit. Because currently, where we are right now, we can't find the limit of this. It's going to be over 0. So we have to continue simplifying. Okay? So, this becomes the limit. You cannot leave out this limit h approaches 0. If this limit thing, you can't leave it out. Yeah, when they mark at the end of the year, if you leave this out, you lose a mark. You cannot. Okay? So let's do the FOIL expansion here. So 2h plus 2h, that's 4h squared, plus 2h times 3, okay, so that's 6h, plus 3 times 2h, so that's another 6h, plus 3 times 3, that gives us 9, minus 9 all over h. Okay, that's what we have now. Okay, so let's simplify that. Obviously, we're gonna put our like terms together. So that becomes the limit as h approaches naught of 4h squared. 6h plus 6h is what? 12h, right? 12h plus 9. Oh, that then cancels out. That 9 cancels out, it becomes 0. So that one is gone over h. Okay. What if we factor out h from there? Let's only factor out h, right?
Yes,
Let's leave the coefficient alone. Okay. So it becomes the limit is h approaches naught. Take the h out, so that becomes 4h plus 12 over h. Now they can cross each other out. Okay, and when they do cross each other out, we're going to find the limit is h approaches naught of 4h plus 12. Remember, h is approaching naught, so that means here it's naught, isn't it? So this whole thing just becomes naught. So we mean the limit that you left with is the 12 here. That's what you left with. Because that h was going to become naught, making everything naught. Remember, if you multiply with naught, it's just naught. So this limit is equal to 12.
So can you say
This becomes naught because h is approaching naught.
yes.
So you're only left with the 12 there, and that's your answer.
4 times naught.
4 times naught is naught.
So then the answer is going to be 12 because 4 times naught is naught. You see?
Okay.
Right, the limit of a constant, because 7 is a constant, right? It's got no variables with it. But it's as x approaches 2. So there's no x there, right? So what happens to that limit is this. For part E, the limit is x approaches 2 of a constant 7 is just the 7 itself. So when you take the limit of a constant, it's just the actual constant itself. So the limit of 6 is just 6. The limit of 10 million is just 10 million.
So
Because there's no x.
They know variable.
you just leave it like
Yeah, you just leave it like that. That's exactly what it means. That's why we could take this 12 as a limit. That's how we could do that. Okay? Because remember, when you have a limit, you are allowed to take the limit of each term one by one. That's allowed.
Yeah.
Of which the limit of 12 will be just 12 itself. And the limit of that will be naught because everything is naught.